In question number 11, the diagram shows the curve y is equals to root x sine 2x for x greater than 0 and less than half pi. The curve has a maximum point at m where x is equals to a. Show that tan 2a is equals to minus 4a. Now, as it has a maximum point at m, what we can do in this question is we'll first find the dy by dx and put it equals to 0. So we'll take this as u and this as v. So as u is root x or x power half, so u dash would be half x to the power of minus half, and v is sine of 2x. So v dash would be, so derivative of sine is cos 2x and the derivative of 2x is 2. Now substituting this in the formula vu dash, so that will become half x power minus half into sine 2x plus v uv dash. So this will be x power half into 2 cos of 2x. And now we can put it equals to 0. Now we'll to solve this, we'll bring it on the left hand side, any of these terms. So let's bring half x over here. So this will be half, and let's bring the x in the denominator as well. So half root x sine 2x is equals to 2x power half cos of 2x. Now this is root x and this is root x. When it multiplies, that will become x. 2 and 2 will multiply to become 4. We'll get sine 2x is equals to 4x cos of 2x. Sin 2x upon cos of 2x will become tan of 2x is equals to 4x. Now the maximum point is at x is equals to a, so we can just simply write it as tan of 2a is equals to 4a. Now it says in part B that show by calculation that a is between 0.9 and 0.95. So in the first step, we will make sure that we write it as tan of 2a minus 4a is equals to 0. Now, this is a very common mistake students make. They forget to bring the a, this term on the left hand side and make it equals to 0, and then try plugging in the values, and they do not get a change of sign. So this is the first step you will have to do. Now you'll plug in the value 0.9. So when I do tan 2 into 0.9 minus 4 into 0.9, what we'll get is, so tan into 2 into 0.9, and we have to make sure the calculator should be in radian mode. So converting the calculator first to radian mode, we'll write it as tan of 2 into 0.9 minus 4 into 0.9, and we are getting minus 7.88. And now taking 0.95 as our value. So when we substitute 0.95, we'll get tan of 2 into 0.95 minus 4 into 0.95, and that becomes, okay, so why am I getting negative in both the cases? Wait. Okay, so that was minus 4a. So just have to make a correction. We should have had a negative sign over here, which would have made this as negative 4a. So this would have become a plus 4a over here. And then let's try and do it again. So now substituting the values again, but with a positive sign. So this is giving positive 0.87, as this is a plus over here. And then when we do tan into 2 into 0.9 plus 4 into 0.9, we are getting minus 0.686. So this change of sign basically represents that 0.686, that the root lies, or the value of a lies between 0.9 and 0.95. It says that show that if a sequence of values given by the iterative formula is given like this, converges, then it converges to A. So what we'll have to do is that the given equation that we had over here, okay, where was it? Yeah, tan 2A is equals to 4A. So we had tan 2A is equals to 4A, and we have to show that it converges to A. So we'll try and rearrange our equation in this form. Now, what we can do is, and let's not get confused with this term over here, because, well, we can just simply write it as 2a is equals to tan inverse of 4a or 4x. Now, this thing over here, we'll try and use an identity over here. So an identity that we can use for tan is, okay, so one of the identities is tan of x is equals to 1 upon pi minus 90 minus tan of x. So that is 90 minus tan of x. Now, once we use this identity over here, or instead it is pi minus tan of x. And we can confirm this identity as well. So let's say if we take a value of tan as any value we can take over here, let's take tan 30 over here. Let's do it in terms of degrees first. So to confirm this identity, what we'll do is we'll write tan of 30. So that is root 3 upon 3. And then we'll check if it is the same as 1 upon 180 minus tan of 30. So 180, okay, so that would be pi. So pi minus, so where's pi? Pi minus tan of, but we're doing it in degrees now. So I think let me just confirm the identity over here, because we'll have to use an identity over here. We already have 2a is equals to tan inverse of 4a. So a would be is equals to tan inverse of 4a, and this will basically be dividing by 2 over here. And now what the only thing is, okay, so again, I missed out on the negative sign over here. So this was a minus 4a over here. Now it becomes clear. So if we have tan inverse of minus x over here, this is the same as writing pi minus tan of x. So this is the same thing as pi minus tan of x. So in place of, once we get tan inverse of minus 4a, we can write it as pi minus tan inverse of 4a, or x basically is the same thing. And then this 2 divides over here, so we can write 2 over here, and we'll get the expression over here like this. And in part D, it says use the iterative formula to calculate a correct to 4 decimal place. Now, this thing is the this part is the most simplest one. We start off with the initial value, and we can take the initial values between 0.9 and 0.95. So let's take the initial value of a as 0.925. So we'll get 1 upon 2 into pi minus tan inverse of 4 into 0.925, and then we'll keep on substituting until we get a constant answer. So we'll get 1 upon 2 bracket pi bracket. Okay, so we get pi my 1 upon 2 bracket pi minus shift tan inverse of 4 into 0.925. So we are getting, okay, and again, I forgot to do one very important thing, that was to make sure the calculator is in radian mode. So we'll write it again, 1 upon 2 bracket pi minus tan inverse of 4 into 0.925, and we are getting 0.9173, and we have to write all of these to 6 decimal place. So 91738, and then substitute it back over here, and we are getting the second answer is 0.918425, and then we get 918281, and then we are getting 918301, and then we are getting 0.918298, and then we are again getting 0.918298. So we are getting the same answer again, and as we have to give our answer final to calculate a correct to 4 decimal places. So to 4 decimal places, we are getting 0.91829 consistently now. Even if I keep on substituting this, we are still getting the same answer. So the final value for A will be 0. So for 4 decimal place, this will become a 3. So 9183 would be the final value for A.